Hello dear friends, I am here with a new tutorial. In this tutorial we are going to create a correct propagation model on a geometry. This geometry is the same geometry which is related to autofrettage process in our previous tutorial. Let's start with drawing our geometry. Our geometry is a two-dimensional cylindrical tube which has a diameter. Inner diameter is 3 mm and outer diameter is 7 mm. First of all, I will create a grid, and I have to edit it because the size is not appropriate for my geometry. -5 to 5. I mean the origin is going to be in the middle of the grid. -5 and 5. Now our origin is in the middle of our grid, and the spacing is 0.1. It's okay. 0.1. The next step is creating the circles, geometry mesh, and curves. Circle, center and radius, add. Center is here. Also we can define from this point. And the inner radius is of 1.5 mm and the outer radius is 3.5 mm. Okay, we create. The next step is creating a mesh. To create a mesh, I have to divide these two circles in a specific division. Curve division. Let's say 200. 200 is a huge value. 100. This is okay, and let's try the same division. Smaller diameter. It is pretty good. Okay. And planar. Tree mesh, select all entities. It looks fine, I think. Yeah. But I have to define our analysis type as planar. Okay, now I am going to hide the grid. Okay, let's follow the procedures. The second step is the time. This is the time. Our time will be in a second, and the solution will be a linear with respect to our time. And material, standard material, Young modulus is 210 gigapascal, means megapascal. 0.3 is the Poisson ratio, and I have to select the geometries, elements, add. I will close. Add the elements, all entities. This is the number of elements, 2000 or around 3000. Okay. And I have to define my geometry as deformable. elements, all elements. It's also okay. Let's come to crack definitions. That is the important. There are two types of crack models, J integral and 2D VCCT. I'm going to use this crack model for my study. This is two-dimensional geometry, and it will be a template. And in the crack propagation menu, we have a lot of models in here: fatigue model, direct, and both of them, and also fatigue period if it's selected, and maximum crack growth increment also going to be defined, and other definitions available in here according to your crack propagation model you can define. And here I will select the direct crack propagation, and for the crack growth method I will add an initial crack to here, and in the software I can select any age of elements can be defined as initial crack here, and therefore I will select the split element, age or phase. After the selection, the criteria is important in here. There are some other criteria, but I'm going to use the total energy release rate because I have some information for this value, and therefore I can calculate the total energy release rate. I will show you how to do this. Let's go back our board. The total energy rate can be calculated with this equation, and this equation is connected to the other two equations, K and Y. K is the stress intensity factor, and this K value is depending on pressure, crack length, and Y is we can consider the Y is as a constant. The equation is here, and only characteristic is the Poisson ratio, and the other values are the constant. And with this information we can calculate the K and also G. The K is the stress intensity factor, as I told, and there is a figure in here which presents the stress intensity factor with respect to Young modulus. There are some material groups here, and the red region is the metallic materials here, and the steel is take place around here. The stress intensity factor is approximately 80-90, but for the metals the stress intensity factor K is starting from the 50 megapascal square root of meter, and it goes according to properties of the material. We should consider that this value is directly depends on the Young modulus of the material. I have made some calculations in here to calculate the total energy release rate, and my material which I defined is a linear elastic material, and in accordance with this information the stress intensity factor is around 90 megapascal meter square root of meter, and the total energy release rate is 0.03, and I'm going to define this value. However, here is the parameter A is the crack length. This crack length can be changed according to your model. Let's recalculate this value according to our crack length, because This geometry is taken from a previous study. You can see the meshes in here, and my geometry has a different type of mesh, and therefore I have to calculate the total energy release rate depends on the crack length. For example, I will open the grid. Here is the horizontal x-axis and the radius is 1.5 millimeter in here, and I'm going to use this h as the initial crack. Let's measure. Here and here. The length is written in here 0.1. I will take all value and I will go to my Excel. I prepared an Excel. Put here the G value, total energy release rate, and stress intensity factor changed. And let's define this value to Marc Mentat software. 0.048 will be enough. 0.048. Okay, this will be enough. This is the maximum crack growth increment. I will select 0.5. This is the increment of the crack. Okay, now we prepared the crack properties as a template. Now I am going to add the initiator, mesh splitting, template crack, this is the crack one, and H, add this H. I select and add the selection. Okay. The next step is applying the boundaries. First of all, I have to fix the geometry from two nodes. Let's say the first node in here, the second node, and okay. This fix X and Y, and also rotation in Z. We can define it. And H load, pressure. Let's define an enormous pressure, megapascal, force per unit area, and the table should be defined in here. And the curve, this is the curve, and apply. Okay. Pressure is applied. After this point, I'm going to define a remesh criteria, advancing from triangle. With the increment frequency is 0.5 and minimum H length can be 0.1. The mesh body is the deformable body, which is defined in here. Okay. After this step, the load case definition is the static analysis, and there is no contact table. There is a global remeshing criteria. I have to select this, and also there is the crack initiator. All the crack initiators are going to be selected. Okay. I will increase the number of steps. That's all. And let's define the job. Name of job is the crack model. large strings should be activated because there is a separation, and this load case will be solved. And what results we are going to look at, it directly depends on your request. That's okay. Let's check our model. There is no errors, and run and submit. Our solution is start. Our solution is done with an error, but we have some increment. It says that there's a solution. Let's look at the solution. Open the post file. I would like to hide the grid. I will select the energy release rate, and let's follow. This is the first step, and we create initial crack in here, and the energy concentration in here is some amount of value, but it will increase by increasing the pressure. Yes. Crack occurred when it reached the total energy release rate. For this geometry, there is such this crack model on the cylinder, and let's catch which pressure leads to fracture, and this is the last point. And let's go to global variables and cracking variables. Here is the stress intensity. It is 100 megapascal square root of meter, and total energy release rate is 0.043. When it reached the 0.0048, the crack or fracture done. And let's look at the boundary. We reached the 6072 megapascal. In the next step, 6080 megapascal, and fracture done. Let's check the stress values here. The equivalent of stresses are around over of the 1000 megapascal. It is huge amount of the stress on the surface. What parameters can be investigated? In the cracking variables, we see the total G and stress intensity factor, and also stress intensity mode 1. In the cracking models, there are 3 types of the cracking models, and I would like to show you. It's not here. It should be around here. Yeah. There are 3 types of modes. This is the opening modes. This is the mode 1, and our model is fractured with the mode 1. And another mode is sliding models, and also the third one is the tearing mode. And according to the model, the applied pressure and the geometry of your model, you can also design different type of modes, and also you can define different modes G factor. in the screen. Let's see that. There are two types of modes, and you can select the individual modes, and also you can define user with the total energy release rate. Now it is going to be automatically calculated. Okay friends, the tutorial is done now. If there are anything you'd like to ask, you can write in the comment section. See you in the next tutorial.